What if you fell into a black hole? Have you ever wondered what would happen if you fell into a black hole? It's one of the most fascinating questions in all of science. Black holes are often portrayed as cosmic monsters that swallow everything in their path. Movies show astronauts disappearing forever into endless darkness. But what would actually happen according to modern physics? Would you be crushed instantly? Could you survive for a few moments? And what secrets might lie beyond the point of no return? Let's find out. To understand what would happen, we first need to know what a black hole really is. A black hole is a region of space where gravity becomes incredibly strong. It forms when a massive star runs out of fuel and collapses under its own weight. The matter becomes compressed into an extremely small area, creating a gravitational field so powerful that not even light can escape. That's why black holes appear completely dark. Surrounding every black hole is an invisible boundary called the event horizon. This is often known as the point of no return. Once anything crosses the event horizon, escaping becomes impossible according to our current understanding of physics. Now imagine you're an astronaut floating through space. At first, the black hole might not look very dramatic. From a distance, it could appear as a dark sphere surrounded by distorted light. The gravity of the black hole bends space itself, causing strange visual effects around it. Stars behind the black hole would appear stretched and warped. Light would curve around the object, creating a glowing ring known as gravitational lensing. As you move closer, things begin to get very strange. One of the first effects you would notice involves time. According to Einstein's theory of relativity, gravity affects the flow of time. The stronger the gravitational field, the slower time passes. If your friends were watching you from a safe distance, they would see your movements slow down as you approach the black hole. To them, it might seem like you are moving in slow motion. In fact, from their perspective, you may appear to freeze near the event horizon, but from your own perspective, time would feel completely normal. You wouldn't notice anything unusual about your watch or your heartbeat. This is one of the strangest consequences of relativity. Two observers can experience time differently, and both can be correct. As you continue falling, another phenomenon begins to dominate. Scientists call it spaghettification. Despite the funny name, the process is anything but pleasant. The gravity near a black hole changes dramatically over very short distances. If your feet are slightly closer to the black hole than your head, they experience a stronger gravitational pull. This difference is called a tidal force. The result is that your body would begin stretching lengthwise while being compressed sideways. Imagine being pulled like a piece of spaghetti. For smaller black holes, these tidal forces become deadly long before you reach the event horizon. Your body would be stretched apart atom by atom. However, things are different for supermassive black holes. These enormous black holes found at the centers of galaxies can contain millions or even billions of times the mass of our Sun. Because they are so large, the tidal forces near the event horizon are much weaker. In theory, you might cross the event horizon of a supermassive black hole without immediately noticing anything unusual, at least for a short time. So what happens after crossing the event horizon? This is where science enters one of its greatest mysteries. Once inside, every possible path through space and time leads deeper toward the center. No matter how powerful your spacecraft is, escape becomes impossible. It's not simply that the gravity is too strong. The structure of space-time itself is directing you inward. At the center of the black hole lies what physicists call a singularity. According to current equations, the singularity is a point where density becomes infinite and our understanding of physics breaks down. But many scientists believe this description is incomplete. The laws of quantum mechanics and gravity do not yet fit together perfectly. Because of this, nobody knows exactly what happens at the singularity. Some theories suggest information could be preserved in ways we don't yet understand. Others propose that black holes may connect to other regions of space. A few speculative ideas even imagine links to entirely different universes. At the moment, there is no evidence proving these possibilities. They remain fascinating ideas rather than established facts. Another interesting question is whether anyone would ever see you fall into the black hole. The answer depends on perspective. You would continue your journey inward, but distant observers would see your image become dimmer and redder over time. The